Okay, moving to the next example, fx equals sin x. So fx minus fc. Now someone tell me the formula of sin c minus sin d. Sin c minus sin d formula. Cos c plus d by 2 into sin c minus d by 2. Yes, apply it. 2 cos x plus c by 2 into sin x minus c by 2. So 2, then mod x plus c by 2 cos x plus c by 2 into mod sin x minus c by 2. Okay. Now we can use the formula that cos theta is always less or equal to 1, right? We know that cos theta, sin theta, these are always less or equal to 1. So we are using it over there. So we can write this whole quantity will be less or equal to 2 into 1. Okay. Again we know that another formula that sin theta is always less or equal to theta, right? So from here what we can write, this is our theta part. So we can write this sin x minus c by 2 will be less or equal to x minus c by 2. It's mod. Okay. Then 2 and 2 will be cancelled out and it will become x minus c, which is obviously less than delta, which we are taking as epsilon. So this is our required value of delta. Here delta equals epsilon and the function is continuous on R. Okay. Similarly, you can solve the next example also, fx equals cos x. Exactly the same thing. This will be your homework. Question number 5. Okay. Now moving to the next part, which is discontinuous function. Discontinuous function. Though this part is not specifically mentioned in syllabus, but we have to know it because for the next theorems on continuity, we need that concept of discontinuity. So when we will say the function is discontinuous, that means the function is not continuous. That is, there is some problem in facing all the continuous criteria by that function. That is, there is some fault to meet all the conditions for being a continuous function, right? Now there are two types of discontinuity. Number one is called removable discontinuity. and number 2 is called non-removable discontinuity. It is quite clear from the name that for removable discontinuity, it isn't a serious thing, right? We can easily remove it. So what type of discontinuity is called removable discontinuity? The type where, now if we use the preliminary concept of continuous function, that means this condition, limit extending to c plus fx equals limit extending to c minus fx equals fc, right? That was the preliminary concept or preliminary condition for being continuous. Now depending on this condition, we will specify different type of discontinuity. So number 1 was, we were talking about removable discontinuity. Now when we will say that discontinuity is removable, if limit extending to c plus fx equals limit extending to c minus fx, but they are different from fc. Okay, if this criteria meets, that is left hand limit and right hand limit both exist, but they are different from the functional value, then we can easily remove that type of discontinuity just by changing the functional value at the point c, right? So this type of discontinuity is called a removable discontinuity. Now let's get one example for such type of discontinuity. Example, test the discontinuity of fx equals x sine 1 by x when x not equal to 0 and 1 when x equal to 0. Okay, that means we have to check the left hand limit at the point 0, then right hand limit at the point 0, and then the functional value at the point 0. Now can someone tell me what is the functional value at the point 0, that is what is the value of f0? One. Yes, this is given here, that is f0 is equal to 1. Now starting with limit extending to 0 plus fx. What is the value of that function at the point, limiting value of the function at the point 0? Zero. Similarly, limit extending to 0 minus fx, this is also 0. That means this value and this value both are equal, right? But they are not equal with f0 because f0 takes the value 1. So this is an example of removable discontinuity. Okay. Next is non-removable type of discontinuity. Now for non-removable discontinuity, there are few types of discontinuity. Number one is called discontinuity of first type. Discontinuity of first type or ordinary discontinuity or jump type discontinuity. It has several names. Okay. The first type of non-removable discontinuity is either called discontinuity of first type or ordinary discontinuity or jump type discontinuity. And what is the definition or what is the criteria? The criteria is if limit extending to c plus fx and extending to c minus fx both exists but not equal. Okay, this is the criteria. That is, both left hand limit and right hand limit exist but they are not equal. Then this type of discontinuity is said to be a discontinuity of first type or jump type. And here one thing also occurred in that function, which is called jump of the function. And jump of the function is defined as the difference between the two values. That is, the limiting value at the point plus minus the limiting value at the point minus. This is called the jump of the function. Okay. This is called jump type of discontinuity or first type of discontinuity. Remember, both left hand limit and right hand limit both should exist. Not like that one is existing and another one does not exist. No. Then this wouldn't call a jump type of discontinuity. This will be another type of discontinuity. But here both should exist but they are not equal. Okay. Now let's get one example. Let's take signum function, our very known signum function. Signum x when x not equal to 0 and 0 when x equal to 0. Okay, at x equal to 0. That means at the point x equal to 0 we have to find out the discontinuity of that function. Now someone tell me how to define signum function. What's the value of signum function? How to define it? X by mod of x when x not equal to 0, and when x equal to 0 then 0. Yes, that means it will take the value x by x which is equal to 1 when x greater than 0, minus 1 when x less than 0, and 0 when x equal to 0. This is signum function. We have to check the continuity at the point x equal to 0. So start it. Left hand limit, right hand limit, check it. This is very easy. You all have done it in 11th or 12th standard. Find out the limits. What's the right hand limit? 1. And the left hand limit? -1. Both are not equal. So this is jump type discontinuity. And what is the jump of the function? Compute this, you know the formula. What is the jump? 0. 2. Yes, because the value was first the plus value, that means the right hand limit, minus the left hand limit. That is 1 minus -1, which is equal to 2. Okay. Next type of non-removable discontinuity is known as discontinuity of second type. Discontinuity of second type. Okay, and what is the definition? Here is if either limit extending to c plus fx or limit extending to c minus fx or both does not exist at x equals c. Okay, that means the criteria is either the left hand limit or the right hand limit or both is not existing at the point. Then we will say this is a discontinuity of second type. Can anyone give me one example of such type of discontinuity? We have solved many examples in limit of such type of discontinuous functions. I'm giving it. Consider the function fx equals this. at x equals 0. Okay. Now check for this part. You have to check limit extending to 0 plus sine 1 by x and limit extending to 0 minus sine 1 by x. You have already calculated the limit at extending to 0 sine 1 by x. What is the limit? Zero. Anyone else? This limit does not exist. Can't you remember? Limit extending to 0 sine 1 by x does not exist. We have proved it in several ways, using Cauchy's criteria, using sequential criteria. Go and check your copy of limit function. This limit does not exist. So obviously 0 plus and 0 minus both are also doesn't exist. So this is an example of second type of discontinuity. Okay, where both the 0 plus limit and 0 minus limit both does not exist. Both don't exist actually. Both don't exist. So this is the second type of discontinuity. Next is another type of discontinuity, except from non-removable and removable one. There is another type of discontinuity which is called piecewise continuous function. Piecewise continuous function or piecewise discontinuity. Okay. Here we will discuss the continuity on an interval. So let the definition is, let f be a function on closed interval AB, and if number 1, f is continuous on closed AB except for a finite number of discontinuity, in open AB. Number 2, f of a plus, f of b minus both exist. And number 3, points of discontinuities are jump type. Then f is said to be a piecewise continuous function. So for being a piecewise continuous function on an interval, a function should satisfy 3 criteria. Number 1, it is continuous throughout the open interval AB except for a finite number of point of discontinuity. Okay, in the interval there are infinitely many points, open AB or in closed AB, but it should be continuous on all that point except there exists some finite number of points where it is discontinuous. Okay, Number 2 criteria is at the left hand point, that is A, the right hand limit should exist, that is f of a plus, and at the right end point of the interval, which is B, the left end limit or left hand limit, that is f of b minus, should exist. Okay. And number 3, all that type of finite number of discontinuity which we have discussed about, these are all should be jump type discontinuity. Okay, not any other type of discontinuity. These all should be jump type of discontinuity. If these three conditions satisfied by a function, then we will say the function is a piecewise continuous function. Now get one example for such type of function. Write down example. If x equals 4 minus x when 0 less or equal to x less than 1, 4 when x equal to 1, 6 minus x when 1 less than x less or equal to 2. Check if is a piecewise continuous function or not. Check if is a piecewise continuous function or not. Now at first someone tell me what is the interval here. That is where the function is defined. Okay. Concept or the question? Question, okay. The question is fx equals 4 minus x when 0 less or equal to x less than 1, then 4 when x equals to 1, and 6 minus x when 1 less than x less or equal to 2. Then check if is a piecewise continuous function or not. Now I am asking that what is the domain of that function fx, that is where the function is defined. What will be the interval? Close every interval. What will be that? Someone is saying, Sarojini is saying 0, 1. And anyone else? Yes, it is 0, 2. Because check this point. It is defined for 0 less or equal to x and ended at x less or equal to 2. So here is the interval is 0, 2. So in the next line we are writing defined on 0, 2. Now moving for the first condition, that is fx should be continuous on the open interval 0, 2 except for some finite number of point of discontinuity. Now can you tell me from the definition of fx, that is the given value of fx, what could be the point of discontinuity? Between 0, 2, what could be the point of discontinuity of fx? That is at what point fx could be discontinuous? fx was this. That was our fx. One. Yes, correct. The rule is how to check that what could be the point of discontinuity is to check the breaking point. Here check from 0, starting from 0 and less than 1, the function is taking the same value. So there is no chance of discontinuity. But at 1, at the left hand side there is one value, at the point 1 there is another value, and for at greater than 1 there is some another value. So 1 could be the point of discontinuity. So we have to check at 1. So check the continuity at x equal to 1. That is limit extending to 1 plus fx and limit extending to 1 minus fx. Check both the limits. Five and 3. Right. 1 plus, it will take the value 6 minus x. Put the value x equal to 1, you will get 6 minus 1 equals 5. And similarly